Okay, guys, you are going to do math review on your own. You'll write down your problems, pause the video, solve it, and then unpause the video to see if you did it right. Now, I know it's really easy to just watch it and copy it as I do it, but sorry, I want you to make sure you can actually do it. I want you getting better at solving equations with fractions, and I want you to understand systems of equations. So please attempt it. When you're done, unpause the video and then check your work. Anything you did wrong, make the corrections. So go ahead and write down the problems, pause the video, solve it, and then come back and unpause the video. Okay, I'm assuming that you've already solved it, so I am going to show you the correct answers. So I have 3/4 b minus 1/2 equals 2/3 plus 5/6, and this is 2/3 b. When I saw the 4 and 2, I thought, oh, I can use 4, but then we threw in the 3. Okay, so now I'm thinking 12. I know 4 goes into 12, 2 goes into 12, 3 goes into 12, and 6 also goes into 12. It's not going to be 6 because 4 can't go into 6. So I'm going to multiply everything by 12 because 4, 2, 3, and 6 are all common factors of 12. Okay, when I do that, 12 divided by 4 gives me 3. 12 divided by 2 gives me 6. 12 divided by 3 gives me 4. And 12 divided by 6 gives me 2. Okay, so now I'm going to rewrite this without my denominators. So I now have 3, which is in blue, times 3b, which was my original numerator, minus 1 times 6, which is in blue, equals 2 times 4, which is in blue, plus 5 times 2, which is in blue. Okay, I'm now going to multiply through. 3 times 3 is 9b, minus 1 times 6, which is 6, equals 2 times 4, which is 8. Sorry, hold on. And then 5 times 2, which is 10. Okay, so just let me double check everything. It looks good. My subtraction is going to become addition. I'm going to add its opposite. So my positive 6 is going to become a negative 6. Oh, up here. 2 times 4, I made a mistake. This is 2b times 4, which means that this is 8b plus 10. Okay, now I'm going to combine like terms. I'm going to subtract 8b from both sides, which is just going to leave me with b plus a negative 6 equals 10. I'm then going to add 6 to both sides, and b is going to equal 16. So hopefully that is what you got. So let me double check everything. 3/4 b minus 1/2 equals 2/3 b plus 5/6. I multiplied everything by 12. 4 goes into 12 3 times 3 times 3 times b is 9b. 2 goes into 12 6, which is negative 6. 3 goes into 12 4 times, which is 8b. And 6 goes into 12 2 times, which is 10. Yep, so b equals 16. If you did anything wrong, please correct it. Hopefully you're getting better at cross-canceling. You're getting better at finding a number that all of them are common factors of, and you're remembering to multiply by all terms. Okay, now we're going to look at our substitution. I have x plus 5y equals 1, and I have 2x plus 3y equals 9. Both of them are in standard form. Normally, if they're both in standard form, I would use elimination. But we haven't learned elimination, so we can still use substitution. but I need to get it to either say x equals something or y equals something, and neither one of those say that. Okay, I'm going to erase the work from here because you can always go back and replay it and pause it. Okay, and I'm going to take my x plus 5y equals 1. This is the easiest one for me to move and use for substitution because I can minus 5y from both sides and I get x equals negative 5y plus 1. I can now substitute for x. So everywhere there's an x, I'm going to plug in negative 5y plus 1. I could have moved my 2x plus 3y equals 9. I could have moved my 2x over, and then I would have to divide everything by 3, and I'd end up with a fraction, and I'm trying to stay away from fractions. So that's why I chose x plus 5y equals 1. But I could have done either one. It wouldn't have mattered. Okay, so now I have 2x plus 3y equals 9. I'm going to rewrite this, and everywhere there's an x, I'm going to plug in this guy here, negative 5y plus 1. So it's going to go 2. I'm going to put my x in parentheses, and I'm going to substitute negative 5y plus 1. And then I'm going to continue with my equation, plus 3y equals 9. Now I'm going to distribute my 2 to everything in the parentheses. So 2 times negative 5y plus 1, 5y, comma, not comma, parenthesis. So I want to show that I'm multiplying. Plus 2 times 1 plus 3y equals 9. So I'm showing that I'm distributing. 2 times negative 5y is negative 10y. Plus 2 times 1 is 2. Plus 3y equals 9. I can combine like terms, my negative 10y and my 3y. I have a negative and a positive. My signs are not the same, so I subtract. That gives me 7y. I have more negatives than positives, so it's a negative 7y. Plus 2 equals 9. I'm then going to combine like terms. I'm going to, instead of adding 2, I'm going to subtract 2 from both sides. I get negative 7y equals 7 because 9 minus 2 is 7. I divide both sides by negative 7, and y equals negative 1 because a positive divided by a negative is a negative. Okay, so now I know that y equals negative 1. And I'm going to take it and I'm going to plug it back in to x plus 5y equals 1. So I'm going to go x plus 5. And I now know that y equals negative 1. So everywhere there's a y, I'm going to plug in a negative 1. So instead of y, I'm going to put in negative 1 equals 1. X plus 5 times negative 1 is negative 5 equals 1. I'm going to add 5 to both sides. Y equals 6. Or sorry, not y, x. X equals 6. My ordered pair is going to be 6, negative 1 because my x equals 6 and my y equals negative 1. Hopefully you got that correct. It's not hard, it's just a lot of work. Okay, you are now going to need your practice book. Hold on, let me tell you which page you need in your practice book. We're going to skip a few pages. And you are going to turn to page 113. So pause the video and get your practice book out. Okay, in your agenda, please write down finish pages 113 to 116. So that is what we're going to work on, and you are going to finish the pages. So I'm going to do a couple of problems with you, and then you're going to do the other problems by yourself, and whatever you do not finish will become homework. Okay, so go ahead and turn to page 113. We're going to have some new terms today, and we're going to pair them with some old terms so you understand what it is that we're talking about. So it's new concepts I guess not really new concepts. It's old concepts paired with new terminology. Okay, so it says functions as mappings from one set to another. So when you see, kind of looks like this Venn diagram, but they don't lap over these oval shapes, it's called mapping. So we're mapping our set or our ordered pairs. So our X and our Y. So the ordered pair you wrote form relations. A relation is any set of ordered pairs. So if I have, when I'm talking about ordered pairs, if I have 5, 4, that's an ordered pair. And my relation is that whenever we have this set, when the X value is 5, my Y value will always be 4. So that's what it's talking about, the relationship. Okay. The first coordinate of the ordered pair that we know, we call it the X, right? In a function, it's called an input. The second coordinate we know as a Y, or our dependent variable. When we're talking about functions, we call it an output. You can also use a mapping to show ordered pairs. A mapping represents two sets of items. Arrows connect the items to represent a relationship between them. When you write the ordered pair for a mapping, you write a set of ordered pairs. A set is a collection of numbers, geometric figures, letters, or other objects that have some characteristics in common. Write the set of ordered pairs that represent each mapping. Okay, so I'm going to show you A, and you're going to go, oh my gosh, this is so easy. Okay, so I'm going to do the ordered pairs over here on the side. So remember, ordered pair has two numbers. So I'm going to start with number 1, and I'm going to follow my arrow down. So 1 goes with 7. So when X is 1, Y is 7. When my independent is 1, the dependent will be 7. When my input is 1, my output will be 7. They all mean exactly the same thing. We just call it input-output when we're talking functions. There's another term we're going to learn in a minute too. Okay, the second ordered pair, I'm going to go with my second number, the 2. I'm going to follow its arrow, and it tells me what the output is when the input is 2. So when my input is 2, my output is going to be 1. Okay, my third ordered pair, I'm going to come over here, and I'm going to go with my 3. I'm going to follow my arrow to 5. So I know that when my input is 3, my output is 5. Okay, my next one is 4. I'm going to follow the arrow, and it goes up to 3. So when my input is 4, my output is 3. I had one number for every input. So 1 was an input, and I only had one number for it. So when I had 1, the answer was 7. When I had 2, the answer was 1. I only had one output for every input. So that means that this mapping represents a function. Okay? Now I'm going to do B. So I'm going to start with 1, and I'm going to follow my arrow to 1. So my ordered pair is when my input's 1, my output is 1. Then I'm going to do my next one. So I'm going to go to 2. When my input is 2, my output is 1. So when my input is 2, my output is 1. So I have 2 outputs with different inputs, right? So my input is 1, my output's 1. My input's 2, my output is still 1. So I have 2 different inputs with the same outputs. That's okay, that's allowed. It can still be considered a function. Okay, now I'm going to go to my next number, which is 3. Oops, let me change the color. I'm now going to follow my 3 to 5. So I know that when my input is 3, my output is 5. I'm then going to follow 4. And when my input is 4, my output is 3. And then I have one more. I'm going to follow 5, and I'm going to go across to 7. So when my input is 5, my output is 7. On my inputs, I only had one output. So when I had 1, it was 1. When I had 2, it was 1. That's okay. When I had 3, it was 5. When I had 4, it was 3. When I had 5, it was 7. So every input has a different output. It doesn't have two different numbers in the y value. So that means that this one is also a function. Okay, I now want you to do C and D. I want you to complete C and D for homework. So you can pause the video and complete C and D, or you can continue with the video and then do C and D once the video is done. It's up to you. Okay, we're now going to create mapping. It says create a mapping from the set of ordered pairs. So I need 2 ovals. So I'm going to take my shapes and I'm going to do, here's 1. There's 2. Okay, now my X is 5 and my Y is 8. My X is 11. My Y is 9. My X is 6. My Y is 8. My X is 8. My Y is 5. Okay, now we really want these in order. So I'm going to write them over here, 5, 11, 6, and 8. And then I'm going to erase this and I'm going to put them in order. So I'm going to go 5, 6, 8, 11. And then I'm going to do the same thing over here, 8, 9, 8, 5. Okay, see how this 8 comes up twice? I'm only going to write it in here once. So I'm going to go 5, 8, 9. Okay, now I'm going to erase that. Now we're going to make our arrows. I think if I go to equations, it will let me do arrows. Yep, there's my arrow. Let's see. Will it let me? I don't think it will. So I am going to not do arrows. I am just going to draw them. Okay. Let's change the color. So 5 went to 8. So I'm going to come over here and I'm going to do 5 goes to 8. 11 goes to 9. 6 goes to 8. And then 8 goes to 5. So let me double check. 5 to 8. 11 to 9, 6 to 8, 8 to 5. So every input only has an arrow to one number. So this one is also a function. Okay, let's do the next one. Sorry, I don't know why it did this or how to get it off. Hold on. There we go. So I want you to try to do B. So let's put our shapes here. There's 1. There's 2. I want you to do it, so pause the video and then come back and check. Okay, so I'm going to do them on the outside so we can place them on the inside. So 3, 4, 9, 8, 3, 7, 4, 20, because I want to keep them in order. So 3, I have 2 3s. 4, and 9. See how I have 2 3s over here? Over on A, I had 2 8s in my output. It's okay to have the same number in my output. It's not okay to have the same number in my input, because that means this 3 is going to go to 2 different numbers. So it's not going to be a function. Okay, and then in order over here, it's going to go 4, 7. Fix that. 7, 8, 20. Okay, now I'm going to connect my arrows. 3 goes to 4. 9 goes to 8. 3 also goes to 7. Because I have 2 arrows coming off the same number in my input, it's not a function. And 4 goes to 20. So hopefully that is the answer that you got. Okay, now it says a function maps each input to one and only one output. In other words, a function has no inputs with more than one output. The domain of a function is a set of all inputs. So all of these numbers over here are my domain. And the range of a function is a set of all the outputs. All of these are my range. And this 2a would be a function because I have one output for every input. But b would not be a function because I have 2 different outputs for one input. Okay, let's go to the next page. It says in each map, show the domain is 1, 2, 3. Sorry, in each mapping, shown the domain is 1, 2, 3, 4. So over here is my domain because those are my inputs. And my range is 1, 3, 7 because those are my outputs. In this one here, it says the relation is a function because I have one arrow going away from each number in my domain. The second one, however, is not a function because I have 2 arrows right here going away from one input. I can only have one arrow going from each input. So hopefully that makes sense. Okay, so it says state why the relationship in the worked example is not a function. So why is this one here not a function? And then state the domain and range for each relation in question 2. Then determine which relations represent functions. They already told you which ones were functions. And then number 5, it says, revisit the set of ordered pairs from the getting started. Determine whether each sequence represents a function. If it is a function, identify its domain and range. So they gave it to us. So we're going to look at those, A and B. So before we get started, I am going to, so question 2 is right here. I'm going to copy and paste. So you understand which ones we're using. Okay, so this, I just took question 2 from the previous page. We have to do our domain and range. Okay, so I'm going to do A and then I'm going to have you guys do B. So I'm going to put domain. And instead of brackets, I don't know what these little guys are called, but they kind of look like brackets, but they end up to a point. So I'm going to do all of my inputs because those are my domains, but I want them in order from least to greatest. So it's going to be 5. So there's 5. 6. 8. And 11. So I got all of them. And then I'm going to do my little funky, I don't know what it's called. It's not a bracket. Okay, and then I'm going to do my range. And my range are my outputs. So, oops. I want to keep them in order of least to greatest. So Let's do this funky little symbol. I have 8, 9, 8, and 5. So 5 is my smallest. I have 8 once, or twice, but I'm going to write it once, and then 9. Okay, so my domain's my inputs, range is my output. Now you do B, and then we will check it on Monday. Okay, so you're going to complete B, and you should answer 3. I already answered it for you. You need to make sure you have it written down. Okay, now it says, determine whether each sequence represents a function. If it's a function, identify its domain and range. So I am going to do 1 for you. So I'm going to highlight my inputs or my domains. Okay, I notice that I don't have any repeating inputs. If I don't have any repeating inputs, then it is a function. So if I had 1 twice on my input, it would not be a function, but I don't. So I'm good. So now I'm going to write my domain. So my domain is going to be all my inputs, 1, 2, 3, 4, 5. And then my range is going to be all my outputs. So my outputs are 5, 8, 11, 14, 17. And I want to keep them in order from least to greatest. So it's going to go 5. They already are in order. 8, 11, 14, and 17. And it is a function. And I know it's a function because I have only 1 output for every input. I don't have any repeated inputs. Okay, now you're going to do B. You're going to check to see if it's a function, and if it's a function, you're going to write the domain and ranges. If it's not a function, you're just going to put not a function, and there won't be any domain or ranges. Okay, we're now going to turn to, that was page 114, so now we're going to be on 115. So go ahead and go to 115. Okay, just a minute, I lost my mouse. 115. We're going to read scenarios, and then you're going to tell if it is a function or not. So functions as mappings from inputs to outputs. You have determined whether sets of ordered pairs represent functions. In this activity, you will examine different situations and determine whether they represent functional relationships. So read each situation and decide whether it fits the definition of a function, and then explain your reasoning. So input, Sue writes a thank you note to her best friend. So she's writing a thank you note. Output, her best friend receives the thank you note. So input, there's a thank you note. Input, Sue writes a thank you note. Output, the best friend receives the thank you note. So only 1 person. It's from Sue to best friend. So we would say this is an input because only Sue's best friend received the thank you note. Or we could say only 1 person received the thank you note. Okay, a TV station broadcasts a football game. So the football game is the input. The output, it appears on televisions in millions of homes. So there's a football game and it goes out to millions of homes. So is that 1 person getting it, or is it a lot of people? So this is not a function because the football game goes out to many homes. So if I was drawing my mapping, I'd have the football game as an input, and it would go out to millions of homes. There would be lots of arrows going out, leaving that input. Okay, there are 4 puppies in a litter. The Smiths adopt 1 puppy. The Jacksons adopt another puppy. And the Fullers adopt the remaining 2 puppies. Okay, this one is easier to see if you map it. Okay, so I have puppy number 1, puppy number 2, puppy number 3, puppy number 4. Okay, now it's going to go to home 1, home 2, home 3, right? So we have the Smiths. So this one's the Smiths. Then we have the Jacksons. And then we have the Fullers. Remember, we can have multiple outputs going to one input, but we can only have one input going to one output. So let's see. Puppy 1 goes to the Smiths. Good so far. Puppy 2 goes to the Jacksons. Good so far. And then the remaining 2 puppies go to the Fullers. So 3 is going to go to 3, and 4 is going to go to 3. I'm okay as long as my inputs don't go to different outputs. So as long as I only have one arrow going from 1, one arrow going from 2, one arrow going 3, and one arrow going from 4, I'm okay. So 3 and 4 can go to the same output. We just can't have different outputs for my input. So this actually is a function. So we would say this is a function because I only have one output for each input. Okay, I want you to do 4, 5, and 6, and then we will check them on Monday. So you can either pause the video and do it now, or you can continue watching and do it for homework. Okay, and then we are going to turn to our last page, which is 116. 116. Go ahead and turn to that page. Okay, this is the last page we're going to do. I'm going to do 1A with you, table A, 3, sequence A, and set A. And then you're going to do mapping B, table B, sequence B, and set B on your own. And then we'll check it on Monday. Okay, so it says analyze the relations in each pair. Determine which relations are functions and which are not functions, and explain. Okay, so I'm going to start with mapping A, 1A. So I'm going to mark it up so I can see it. So 10 has 1 arrow, so I'm good. 11 has 1 arrow, so I'm good. Remember, I'm not worried about my outputs. I'm just worried about my input arrows. 12 has 1 arrow. 13 has 1 arrow. So this one is a function. So it's a function because there is 1 output for every input. I don't have 2 inputs for an output. I have 1 input for every output. So now you're going to do mapping B. So as long as you only have 1 arrow going from the number, you're good. If you have 2 arrows going, then it's not a function. Okay, so now I'm going to look at table 2. So as long as I don't have any repeated numbers for inputs, then I'm good. So I'm going to highlight each number differently unless it's the same number. Then I'm going to highlight the same color. If I highlight more than 1 on my input the same color, then it's not a function. Okay, so I have, sorry, why is this not, there we go. So I have -2, I have -1, I don't know what's going on. I have 0, which is a different color. I have 1. Let's see. Let me try. Okay, I don't know what it is doing. Let's take this off. Okay, well, I'm just going to use a regular old pen. Okay, so -2, we're not going to go over it. I'm going to say, okay, this one's blue. -1 is red. 0 is, that should be orange. One, I don't have any 1s yet, so it's going to be green. I have a -2, but not a +2, so it needs a different color. Okay, so I don't have any of the same colors, so none of my input numbers repeat, so it is a function. Okay, so I'm going to say function because none of my inputs repeat. So if I would have had any of the same numbers in my inputs, then it's not a function. Okay, now I'm going to look at sequence A. Okay, these are sequences. So this is 1, this is 2, this is 3, this is 4, this is 5. So it would look like this. 1, 7. Sequence 2 would be a 10. Sequence 3 would be a 13. Sequence 4 would be a 16. Sequence 5 would be a 19. Remember that my outputs can repeat, but not my inputs. And none of my inputs repeat, therefore it's a function. So, and I'm going to copy exactly what I wrote up above. So it is a function because none of my inputs repeat. Okay, and then we're going to look at set A. Let's see, hopefully it'll let me mark it. So I'm going to go, it's not, why isn't it not letting me? Let's see. There we go. So 2, 2, 2, 2, 2. They're all gray because they're the same number. Because my input repeats, this one is not a function. So not a function because I don't know what is going on with my writing. Oh, it's under equation. Okay, I hit the wrong one. Okay, text box. Set text box. Not a function because my input has a number. And I'm going to put 2 because that's the number that repeats. And my input cannot repeat. Okay, so now you're going to do the same thing with mapping B, table B, sequence B, and set B. And then we will check them, your answers on Monday. So hopefully this makes sense because this is what we're going to be working on for the next few weeks. And I will see you guys on Monday.